All right, so what we're gonna do is, because 2023 isn't open yet, obviously, so let's just look at 2022, and let's just do the day one puzzle because that's usually very easy, and it lets us get used to reading and writing files. Okay, let's see. Let's see if I can make this viewable. Oh my god. Let's just drag it over a little. Okay. So what this says, there's some lore here. We don't really need to read the lore. We just have to skim through and understand what the actual problem here is. Else we can take inventory calories each elf is carrying. Elves take turns writing down carries contained by the various snacks. Each elf separates their own inventory from the previous elf's inventory by a blank line. Suppose the elves finish writing their items calories and end up with this list. Okay, first elf is carrying 1,000, 2,000, 3,000 for 6,000 calories. Second elf is carrying 4,000. In case the elves get hungry and need extra snacks, they need to know which elf to ask. They have to ask how many calories are carried by the elf carrying the most calories. In the example above, this is 24,000 carried by the fourth elf, because I guess this, right, 7,000, 8,000, 9,000, that does add up to 24,000. And then, yeah, so that's the problem. So fairly straightforward. We basically want to do like a vector. Actually, we don't even need to. We can just kind of compute the max as we go. So yeah, let's go ahead and do that. So there's a few ways we can get the input. So the algorithm here is obviously pretty straightforward, but the purpose of working on this right now is to make sure we're familiar with IO in Rust. I don't use Rust at work or anything, so I still have to look things up because I forget it very frequently. But let's say the way we want to invoke this is by running this with an argument, with a file name as the first argument. So what we want to do, let's say, is like cargo run and then input.txt, and then the program will read in the input and then spit out the output on the standard output. So how do we do that? Well, let's see. Rust. How do we read in arguments from Rust? Arguments. Looks like we can just get a vector of strings from env-args collect. So that's exactly what we want. Straightforward. String, I mean, equals args.collect. And because this is advent of code and not like production software, I'm just going to be very loose about error handling. So let file goes to args 1, I believe, and then why is it complaining? Consider borrowing because da 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 da. So we can't actually move it out of the vector. That's fine because we don't really need to take ownership, so we can just borrow it. And then how do we read out the lines from file one at a time? So Rust read lines from the file. Let's see, Rust by example. That's exactly what we want. And in fact, I think this function is something that we will probably use a lot. So let's just paste it. You know, if this was production, I would care about what the license on this code is, but it's not, so don't care. We're just going to use it. And let's do that lines equals to read lines file name. Yeah, that works. And then what we're going to do is we're going to iterate through. Okay. And now we can actually apply the algorithm. So let's start with we can just count. We can just keep track of what the current max is, right? We need to, okay, backing up here. We need two variables for this algorithm. We need one max, which I'll call max, to keep track of how many, what's the ELF that has the most number of calories that we've encountered so far. And then we need a second one, which just tracks how many calories the current ELF has, because if you look at this, when we iterate through this file here, we need to add up 1,000, 2,000, 3,000. That's one variable, and that gives us 6,000. And then we need to keep track of that 6,000 as we go through each of the next ELFs. So that's max. So naming could be better, but whatever. And then we can do this for line and lines. We don't actually need to take ownership of the string, so I can do for line and ampersand lines. And let's do this. We're going to iterate through the file one line at a time. So the first thing we care about is the number of calories. So we need to convert this string into a number. We actually need to consider the empty case first, but let's consider the number case and then go back and edit the lines above. So let calories, I guess, equals to line.parse. And because again, not production code, we're just going to unwrap. We don't really care if it panics. And let's hope that no ELF is carrying more than 2 to the 31, I guess, calories. So what we need to do here is ELF plus equals to calories. So add that number of calories to the current ELF. Okay, but what do we do if we hit an empty line? We have to consider that first, actually. So we need to check if it matches the empty line. If we're not writing Python, sorry. And if that happens, well, what do we need to do? We need to set ELF back to 0 for the next ELF. But we also need to check if the number of calories that the current ELF has exceeds whatever max we're tracking. And if that's the case, we have to set the max to that. So if ELF greater than max, again, not Python, sorry. And yeah, and then we put this in the ELF clause because we don't want to do the calorie counting. If it's an empty line, I think that will just cause this parse to crash on us. And then the last thing is, I don't know how the file's going to be terminated. Is there going to be an empty line at the bottom or not? So just one last check. If ELF is not 0, we need to do one more check. And actually, let's do this. And then we can do again, and then we can just print line P1 for problem 1. As you'll see later, admin to code every day. There's 2 problems, and we should be good to go. So let's copy this into a file. And let's see if that runs or if it crashes. Could not find cargo. Oh, right. We have to do this in here. 24,000. That is indeed the correct number here. Now, I've already solved this, so it gives me the answer that I gave, and it was correct. But I can go to my puzzle input, copy it, input the text, paste it, save, and then I can do input 70,613, and that is what I got. So good. We are good and going. So let's save what we've done so far. I'm going to add text files to the git ignore so we don't check those in by accident. And let's 2022 day 1. Nice and easy. I should actually, let's rename this to 2022 day 1 because I don't want to get this confused with 2023 day 1, obviously. I think I broke Rust Analyzer. That's unfortunate. How do I get it to recognize this again? Can I restart server? Yes. Oh, good. Fantastic. Okay, let's carry on to part 2. By the time you calculate the thing, run out of stacks, you need to show the total calories carried by the top 3 elves carrying the most. Okay, so now instead of just the top 1, which is straightforward, we need to do the top 3. Now we could do this by there's plenty of ways to do this. We could have like 3 variables, max 1, max 2, max 3. But then the logic gets confusing because now you have to compare, like, you have to essentially keep them ordered so that you can compare against the third one. So instead you could just keep a heap of your top 3, and then you can instantly tell what the lowest value in that heap is. It'd be a min heap essentially, and you'd query the minimum value, and if it is and if you're new, so you're iterating through this array, use a min heap. If you encounter a value higher than the minimum value in your min heap, you push it on and you pop the min heap. But that's also kind of complicated to think about a little. Honestly, the easiest thing to do is just to create a vector of the total calories of each elf, call sort, call it a day. So we're going to do that. But first things first, let's clean up the code a little. Let's put the part 1 logic into its own function. And it could take a... It can take a borrowed backup string, I guess. And paste this out in 32. Alright. So, cool thing about Rust, you don't have to say return if it's the last thing. It's kind of the functional language heritage there. And then there's the p1 lines. And we want to borrow lines. Okay, cool. Very nice and readable. And now it's not a great name, obviously, but let's create a P2 function that does something similar. So we are going to, you know, there's obviously more opportunity for reuse. We could, you know, reuse this parsing code. We don't have, so instead of passing a borrowed vector of string to these two functions, we could just parse it in the main into like a vector of elf calorie counts, I guess. But you know, it's fine. Not production code. We just want to get this out. So let's do this. Let's create a vector for line and line. Da, 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 da. What we want to do here is, okay, so we still need a counting elf line, and what we want to do is push elf. We want to do that before we set it to 0. And then yeah, and then what we can do is if elf not equal to 0, we can push elf again. Let's sort. I think we sort it and then we do oh, now we can do fun like functional things. We can do v.iter. Take. We can take the top 3 items. How do I look up documentation for this? We need to check what order the sort is. Is it ascending or descending? It's oh great, it's ascending, so that's not what we want. Is there like an R sort? No. Alright, is there an easy way to do this, or do I have to like implement my own? Well, not implement my own, but like do like my own sort by key. Okay, so, you know, there's a few ways to do it. According to this, it says it doesn't matter which way in terms of performance. I'm surprised by that. So I would expect that sorting then reversing, you know, adds another linear operation afterwards. Whereas sorting by key is yeah, is you know, just sorting but using this other function. I prefer that, so let's do that. I actually prefer the second solution because it's the most readable, I think. It's like much clearer exactly what I'm trying to do here, as opposed to the first one where you have to carefully look at the A and B to see what we're trying to do. Okay, anyway, and then what we can do is v.iter take 3 sum. I think that will work. So what that does is it looks at the vector, takes the top 3 elements and then adds them up, and that's our result. We need to initialize elf. Yeah, and I think this should work. So let's open up our console again. Sorry, I already have a bunch. Cargo run example. So let's see, that does match our example. Good. And so now we can run it on the field input. That's 205,805. That's correct. All right, good job. All right, let's commit that work. 2022 -1.2. And I will make this code available on my GitHub, of course, if you want to take a look at it, though it's really nothing fancy. Yeah, excited to see what's coming this year. Alright, thanks everyone for following. Where is my OBS? I don't see it. Great.